In this video, we're going to learn how to factor quadratic trinomials. Factoring, you can think of it as kind of unmultiplying or undoing a multiply operation. It might be a little easier to understand how to factor if we first look at the results of some multiplications. So consider the problems that I have here. We'll take x plus 3 times x plus 4. Now what I want you to look for is what happens to the 3 and the 4? How are they used in the final result? If we use the expansion boxes to multiply, you see that this is x plus 3 times x plus 4, and you'll notice that the 4 and the 3 end up being coefficients of x, and the 4 and the 3 also multiply to give you 12. Now when we take a look at the final result, the numbers 3 and 4 were added together to give this 7x, and they were multiplied together to give the constant term, which is 12. So if you're going to factor this, one of the things that you might do is look for two numbers that add up to 7 and also multiply to 12. Let's see if that same pattern works for the next one, x plus 5 times x plus 7. So we make the expansion boxes, and we'll notice that the 5 creates a 5x, the 7 creates a 7x, and then when we add all these terms together, the 5 plus 7 gives you 12x, and the 5 times 7 gives you 35. So this pattern is what we base the factoring process on. So let's do a couple of examples. In this example, we want to factor x squared plus 10x plus 21 into two binomials, and we want to look for pairs of factors that add to 10 and multiply to 21. If they're not obvious, the easiest thing to do is to just make factor pairs. So we'll start with 21. 1 and 21. 2 doesn't work. 3 and 7. Well, 3 and 7 do add to 10, so those are the ones we're looking for. So then we know that we can factor this into x plus 3 and x plus 7. And if you do the math, you'll find out that x plus 3 times x plus 7 does indeed equal x squared plus 10x plus 21. Let's take a look at the next one. 7x squared plus 17x plus 72. We're looking for two numbers that multiply to 72 and add to 17. And again, if they're not obvious, you just want to make an organized set of factor pairs of 72. So we can start with 1 and 72. That doesn't work. 2 and 36. No, that doesn't work. How about 3 and 24? No, that doesn't work. Let's see, does 4 work? 4 and 18. Let me put a comma there so those look better. 4 and 18. No, that doesn't work. 5 is not a factor. How about 6 and 12? Nope, that doesn't work. How about 7 and, let's see, 7 is no, 7's not a factor. How about 8 and 9? 8 and 9 work. Took us a long time, but we got there. So the factors then are going to be x plus 8 and x plus 9. Oops. And we'll just do one more. Factor x squared plus 7x plus 6. Well, the first factor pair of 6 that we try, 1 times 6, that works because 1 plus 6 is 7. So these factors are going to be x plus 1 and x plus 6. Here are two examples that I'd like you to try. Please stop the video. Try to factor them. Remember that you make a list of factor pairs first, then do the factoring, and then start the video again when you're done. Okay, so for the first one, the correct factor pair to use is 6 and 5. 6 times 5 is 30. 6 plus 5 is 11. So this factors into x plus 6 times x plus 5. And then for the second problem, x squared plus 19x plus 90, you'll find after you list some factor pairs that the two numbers that we want are 9 and 10. 9 times 10 is 90. 9 plus 10 is 19. So the factors are going to be x plus 10 times x plus 9. Now here are two examples in which the center coefficient is negative, or that is the coefficient of x. So in this case, we're looking for two numbers that multiply to 81 but add up to 18, or negative 18 rather. So we can start with 1 and 81. Well, that doesn't work. About 3 and 27. Nope, that doesn't work. About 9 and 9. Well, 9 and 9 multiply to 81, but they don't add to negative 18. However, negative 9 and negative 9 also multiply to 81, but they add up to negative 18. So these are the numbers that we're looking for, and the factors will be x minus 9 times x minus 9. This can also be written as x minus 9 squared. Now in this example, x squared minus 15x plus 56, we're looking for two numbers that add to negative 15, multiply to 56. So let's write out some factor pairs of 56. 1 and 56, no. 2 and 28, no. 3 doesn't work. 4 and, let's see, that would be 1 and 4 and 14. No, that doesn't work. 5 is not a factor. 6 is not a factor. How about 7 and 8? Well, 7 and 8 multiply to 56, but they don't add to negative 15. However, negative 7 and negative 8 do. So the factors are x minus 7 and x minus 8. Now take a look at these two examples. Please stop the video, try them in your journal, and then restart the video to see the solutions. Okay, in the first case, the two numbers that we want are negative 6 and negative 2, x minus 6 times x minus 2. And here, the numbers that we want are negative 7 and negative 7, x minus 7 times x minus 7, and that can also be written as x minus 7 squared. Now there's one last case that I'd like to bring up, and that is the case where the constant term is negative. Now what this means is that we're looking really for two numbers that multiply to 55 but whose difference is positive 6. So let's try to look for that. In this problem, x squared plus 6x minus 55, well, let's see, 1 and 55, I don't think that'll work. 2, 3, 4, how about 5 and 11? Okay, now 5 and 11 multiply to 55. Negative 5 and 11 multiply to negative 55, and they also add up to 6. So these are the two factors that we're looking for. X minus 5 times x plus 11. Notice that it's important that the negative 5 is the one that's negative, or the 5 is the one that's negative, because if not, you will change the result, and this will not be the correct factoring. So this is the only correct factoring. Now let's take a look at x squared minus 7x minus 60. We're looking for two numbers that multiply to negative 60 that add to negative 7. So let's start writing factor pairs of 60. So we have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12. Okay. Now 5 and 12, they have a difference of 7. If we make the 12 negative, then 5 times negative 12 is negative 60. 5 plus negative 12 is negative 7. So those would be our factors, x plus 5 and x minus 12. In this last example, we can see that the numbers that we're looking for are 6 and negative 3. So the factors are going to be x plus 6 and x minus 3. And we can see that 6 times negative 3 is negative 18. 6 plus negative 3 is 3x. So there are the factors. And finally, I'd like you to try these last two examples and stop the video while you do that. Restart the video when you're done, and I'll run quickly through the answers. Okay, for this first one, the factors that we're looking for are x minus 4 times x plus 3. Negative 4 times 3 is negative 12, and negative 4 plus 3 is negative x, or negative 1x. Here, x squared plus 5x minus 66. The two factors we're looking for are 11 and 6. And specifically, this is going to be x plus 11 times x minus 6. 11 times negative 6 is negative 66. 11 plus negative 6 is 5. So there are the factors. And that concludes this video.